Jerry Slate first approached me about this, he talked about a series of talks by people who were around when some innovations occurred in their particular field. And he asked me if Steve and I would talk about things related to the ARPANET and internet. And so I thought of, well, the thing that I did that I'm still mostly interested in and proud of is the whole issue of internet conferencing. And Steve, of course, was in the area of the actual transport. He was involved in a lot of different networking activities, and his piece of this had to do with worldwide internet conferencing. And so I'll point out when that comes into play. But it's somewhat ironic that the very tool that we're using to do all this, the notion of conferencing over the internet, over some content, is exactly the topic that I worked on for most of my career at least 3 companies. In other words, I would just, I'd go to a new company and do the same thing. And they seem to like it. And to be honest with you, the first time that this really got the full exposure that I always imagined it should have was on March 12th of this year, when everybody suddenly saw a reason for it to exist. People used to look at me with sort of strange glance as to, you want to do what? And suddenly I became, or I felt justified for what I spent a lot of time on. Okay, so let's go to the first slide, I think. Okay, whoops, yeah. So my theme for the last, I gave a talk 2 years ago and I did this slide, so for the last 48 years is basically on the left side of the picture, the process of going from analog to digital, and then fleshing out what could be done in digital to the sort of multimedia expression. At the very same time, life was switching from circuit switch communications to packet switch. And this sort of content and communications changes has been a sort of a theme of what I've done. So just so that you know where I came from, I grew up on Long Island in New York, and I did the normal routine of going to grade school, high school, college. I went to Yale. I worked for a couple of years because I was channeled, as they said, into the defense industry as opposed to going to Vietnam. So I got a 2-way deferment at the U.S. Navy Underwater Sound Lab, which was investigating all sorts of sonar techniques that submarines used in that Cold War era. And then finally, I made it to MIT in 1971 and was there for like 4 years. Probably should have left after 2 of them, but I stuck on. That was the first phase of my life. Let's see, yeah, but here we go. The second phase is the work phase. And that involved really 4 major companies, BBN, CMGI, Genuity, and Level 3 in Colorado. And I'll tell you a little bit more about that. But obviously, most of my time was spent at BBN, and that's certainly the place I enjoyed working the most. And then finally, I retired early because I got an opportunity to do it. And so for the last 15 years or so, in fact, here are the relative time periods I spent doing various things in my life. In other words, 27 years getting ready to do the rest of my life, working for 29 years, and then I've been retired for 15 years so far. Let's see. I hope it goes on for a little longer. This is not, okay. One of the themes I figured out as I was thinking about all this is that the research and demonstration work that I did leads to inventions. I'm not the kind of person who is an inventor as in I'll go into the lab and invent something today. It just happened, and it turned out that it was a pretty good idea, and I came up with, refined it more and more. So people learned that I had a talent for both understanding research as well as having the ability to create explanations of the demonstrations I created of research that ordinary people could understand. And I think that ordinary people could understand requirement is really critical. And I think all scientists and engineers should try and address that issue when they're trying to relate to the rest of the world, because you get so wrapped, as you well know, you get so wrapped up in your own world that you tend to shorthand or short circuit the abilities of explaining things to people in ways that they can get it. And I was also encouraged in my work in in demonstrations to project into the future, to think about what the possibilities, and in my case, it was to think about the possibilities of packet switch networking. Sorry, I knew I had slipped a slide. Okay, so let's go back to make sure I got it. Yeah, there we go. Okay, so my first assignment when I went to BBN in 1974 was to do research on distributed operating systems. And what that meant was how to get the low-level parts of computer systems to work together in a networked environment. So the other part of my job was to accompany ARPA program managers on trips around the world, giving demonstrations of the ARPANET. So that forced me to learn as a fairly young, not the youngest, but fairly young person, how to speak in front of large groups of imposing figures, because these were all military guys. But I enjoyed that a lot, and it was a really great opportunity to see the world, because I went from probably half the world, from Hawaii to Berlin, was how I figured it out once. We didn't go to Asia at all. But being on, at that point, the cutting edge of network research with a mandate to create demonstrations was really a great opportunity to really understand, but it also essentially set the stage for the rest of what I've done. Okay, let's see if I can, okay. Well, yeah, so set the stage for the rest of my career. I talked about that already. So at the beginning in 1975, and I've always, I should back up and say, I've always been involved in applications of computers and networks. I've never been on the hardware side of things. So at the beginning of 1975, when I first started at BBN, the three biggies that we worked on and thought about and used before everybody else was the whole idea of logging into one computer from another computer, and you may be half the world apart from each other. That was the login scenario, using a computer. The second one was transferring files between computers, and I was involved in some of the early protocols for file transfer protocol. And then the third one, the sort of next level up, was the whole notion of email. And we worked a lot on email in the 70s. And in fact, some of you may or may not know this, but I carpooled for 15 years with Ray Tomlinson, who also lived in Lexington, who was the person credited with inventing computer-to-computer email. And he was a wonderful person, and he died a couple of years ago, and still a very fond memory of those 15 years of conversations with Ray on the way from Lexington into Cambridge at BBN. The second aspect of things, which is where I started to lead projects, was the period from 1980 to 1996, 16 years or so at BBN, where I led a number of different projects. And the first one was the Diamond system, which was an extension of email so that it could carry multiple media. It's what we call today email. but then it was a big deal because it was the first time that people got away from just text mail. The next two pieces are what I'm going to be talking about today, a system called MMConf, which was used for shared screens, which is what we're doing right now, and Picture Window, which was a refinement on the old room style video conferencing, so it could really make it possible to do what we do today, which is personal video conferencing. And then after that was happened, I got involved as a department manager in several other things, one of which was something called the Video Information Server, which was treating video as just another media type. It's a lot harder to treat video that way because of the size of the representation. And then finally, the last thing I did at BBN was called Pin Paper, Personal Internet Newspaper. And that was basically using the personalization side of computers and information, and being able to allow a person to define a newspaper that searched all over the internet for stories on topics that they were particularly interested in. And it was that development that eventually got me away from BBN because somebody else came and wanted to buy the technology. But I'll talk more about that in a little bit. So I want to talk a little bit about invention because I started to think about that also. Are these really, what's this creation stuff all about? Very few successful inventors are the only people who have thought of an idea. And I was thinking about that a couple of days ago, and I went over to Wikipedia, and they have a whole long topic called multiple discoveries. And it was showing how many things that we just sort of take for granted and we associate one person with, like Alexander Graham Bell or Darwin or I don't know, but other people like that. They all, most of the important ones have multiple people who either discover it simultaneously, which is sort of kind of weird, or are really just stepping on the shoulders of other people and refining things and taking it a long distance for sure,
Excuse me,
but
Harry.
maybe not as much as you might think.
Harry,
I'm sorry.
yeah. Since you brought up what's a very interesting topic, maybe somebody in this group would like to turn that into a presentation.
It's a great idea. If I had, yes, it was a really neat discovery, which is why I devoted the whole slide to that issue of things that are multiple discoveries. That's a great thing for somebody else to talk about. Yep. Okay, so so the other comment is that innovative ideas require a lot more work to make it successful. The marketing, a certain amount of luck, a lot of work. And I use as the example a trip we took to the Edison National Historic Park, where they had a whole floor dedicated to all these weird things that Edison and his staff invented, quote unquote. But they really went nowhere, and they certainly have no evidence now, or if you invent it, it's only because a lot of things don't exist that are required to make it happen, and it seems trivial now when you see them. So that's one thing. And his comment was, "I never had an idea in my life. My so-called inventions already existed in the environment. I took them out. I've created nothing, nobody does. There's no such thing as an idea being brain-born. Everything comes from the outside." So that was a certain amount of humility for someone who obviously had a big ego and did a lot of things in the invention world, was known as an inventor, saying that, it isn't all that it's cracked. This idea isn't all that it's cracked up to be. So my feeling is that new ideas come from an environment filled with previous ideas that make coming up with the new idea a lot easier. So for example, in my case, there was a whole bunch of things that were innovative that had to be present before I could do anything of what I did. But I took advantage of it. And as I pointed out earlier, I received a lot of encouragement from my employer and their sponsors and things of that. And so that was very much the case I had when I started working at BBN in 1983 on this topic of internet conferencing. And just to sort of standing on the shoulders of other people, I read a paper before I started all this work in the 1968 Fall Joint Computer Conference by Doug Engelbart, the famous researcher at Stanford Research Institute who did invent many different things with his group, including the mouse. That he's basically credited with having produced the first mouse that we all use, or somehow we use it. And in the presentation of this paper that he developed or wrote, he gave what has become known as the mother of all demos. And among other ideas present in his demo was the idea of working collaboratively with a colleague located at a remote location. Great writing there. And whoops. Okay. So here is a video, an excerpt from that demo that gives you the germ of the idea that they were talking about. And you have to remember, this was before the ARPANET. And so all of the video and audio was analog with the computer controlling the switching circuit. So it really wasn't what we're doing right now. It was basically involving a lot of analog video, a lot of analog audio, and a computer intermediating, when things started. But it basically had the idea. Let me play a couple of seconds of this video just to show you what I'm talking about. I was amused at the first thing that happened between them was the famous, that we still do now, "Can you hear me?" So that hasn't been solved even however many years later it is. People are still a little uncomfortable with the notion of speaking to a computer and not knowing necessarily that they're being heard.
Harry, for that
Yes.
time, that was very impressive.
Oh, yes. Oh, absolutely. That's why I say it was considered to be there were so many things shown in that talk that are derivative. Today we have a lot of things that are derived from the same ideas that are in that talk. And certainly what I did was a total derivation of what they did. I just did it in the new environment of packet switch networks. And that was the real change from what they did. But they showed off all the ideas then. But after I saw that paper and I saw that video, actually I didn't see that video then because that video came online later. I read the paper. I wrote a paper called Explorations into Real-Time Multimedia Conferencing, which a little wordy, but it was a paper for an IFIP conference in England. And it was really where I put together describing all the things that we had been doing in this area. And I should just back up for a second and point out the benefit of those downtimes that you occasionally have. And if you're an employer or if you're an employee, it's somewhat related to what Google used to have, which is one day a week to work on whatever you're interested in. It turned out that I took the multimedia email system that we had developed 1 week between Christmas and New Year's when no one was around. I basically took that system and tried to put some of these ideas into it so that we could have synchronous conferencing over documents over distance. And I always credit BBN for having the environment where they allowed us to maybe not always work on the things we were supposed to be working on, but working on some new ideas. And that's what I did during that particular week. But anyway, after working on these ideas for a year, and we were working on them under a DARPA contract because it was part of our mandate to do that kind of stuff. I came up with this system that we eventually called MMConf, Multimedia Conferencing. And I wrote this paper. And this paper is actually critical because it is the basis of things that happened later on. Now, I wanted to say what was different between Engelbart's world and my world. So what had really changed in the 16 years from 1968 to 1984? First of all, the impact of Moore's law on the power of computers. Every couple of years, you get twice the number of transistors on a chip for half the cost. And here is the period of time I'm talking about from, well, not quite 1968, up until 1983
Harry,
or so.
wait a second.
Yeah.
Isn't it twice the number of transistors for the same cost? Or
Well,
you don't get both the halving of the cost and the doubling of the transistors.
okay, I have to admit that I did not remember it exactly right, and I looked it up, and I don't think I really saw it. I didn't come to work it out. You're probably right, John. I appreciate that. Yeah, because I couldn't quite figure it out either. Because then that would be a factor of 4 or something. Anyways, okay, yeah. I stand corrected. Anyway, we went from the Intel 40, what was it called? I think it was a 404 up to an Intel 386 or Motorola 6820, which were the chips that gave rise to so-called personal computers. Now, a personal computer in those days was still, in 1982, was still something that cost $20,000. So it wasn't quite the personal computer we have today. But since Moore's law didn't stop, it is the case that machines got more and more powerful for the same cost. And or they got, you didn't need quite as much power, but you could cut down the cost. Anyway, we all know that. But that was significant in being able to do what I did. Another thing was what was connected to computers. And in the early, 1968 era, you had VT52s connected to IBM 7094s, big hunking piece of metal. This is that's actually Corbido, professor at MIT, standing in the middle at MIT of their computer center. That's what it was in Doug Engelbart's period. And then when I started working, we all had Sun workstations, which were these machines based on the Motorola chip that I talked about. So there was, and furthermore, we went from black and white displays or monochromatic displays to color displays and color bitmap displays as opposed to character-oriented displays. So there were a lot of things that changed in that 16-year period. In terms of communications, we also went from telephone poles with wires and circuit switching to the beginning of the internet, packet switch networks. There was in 1984. There was, that picture on the right shows exactly how many places were up and running on the internet, and there were probably more than that. But it basically shows the idea that there were lots of places you could go in the U.S. And then it went to Europe and all over the rest of the world too. But the point is the communications had changed dramatically. And then finally, I think, is the whole notion of once you move from character-oriented documents to multimedia documents, the expressivity, when you have different kinds of things, opens up the application of all this to many other fields than just the office, if you will. And you'll see some examples of that in just a second. So I want to show you the basic idea of MMConf. And in thinking about it and describing it, I realized it was such a simple idea. What's the big deal? But it turns out it was a simple idea that was headed in the wrong direction at first, and is actually not what is done today in screen sharing or sharing documents. But it was something that got a lot of people thinking of this in the context of the internet. So let me first of all show you the original diagram that appeared in that paper in 1985 of how this system worked. So that's a scan of the diagram in the paper. Here is some annotations on top of that to illustrate it a little better. So what was going on, instead of circuits between different participants, we now had the ability to connect to the internet. And furthermore, we had the ability to have some interesting applications that had essentially a library baked into them, which captured all of their input and output commands. This is, again, I apologize because this is not how it's done today. It's done today essentially with video. What you're seeing right now is a video cast of my screen. But in those days, the way we did it was we very carefully captured all the inputs and outputs, and then relied upon the fact that if three stations are all in the same state, and you feed them the same set of inputs, they will show the same set of outputs. And that's how we achieve this synchronicity between the multiple workstations involved in the conference. That was a pretty, yeah, go ahead.
Would that require that all the different workstations be of very similar architecture?
Let's see now. They had to at least be running the same Windows system. So those were in the days of X11, if you remember that. And so they had the same set of commands. Yes, you're right. There was some, you couldn't, for example, do this on any computer like you can do it today. There were lots more variations on things, of course, in those days, as there weren't just 2 platforms like we see today, or maybe there's 6 platforms. But you're right, though. It did require that a lot of things be very, very similar. And in those days, Sun workstations were the standard working piece of ARPANET researchers, and so or DARPA programs. And so that was something that we could sort of gloss over the details of that. Good point.
Harry, what about lag? What about lag between the connections?
That was one where we didn't try to do anything that was too hard. And in fact, lag is why we didn't do it with video, because the performance of transmitting video across the internet at that point was nowhere near what it is today. And so we couldn't really do what we do today just because the speed was not adequate. And so, but we didn't do anything special to deal with the latency. In fact, what we did was just rely upon, we weren't going to try anything that we knew we couldn't accomplish with the latency that existed already.
So
and that worked out pretty well.
So compression and decompression algorithms weren't really part of the process at that point.
That's correct. Yep. No, it was definitely uncompressed. It was, as I said, but it was actually a small amount of data, and that was the advantage of it, is that you could just, if you typed a character A in a text editor that was under this system, all that would be transmitted across the network was the A, not the pattern of the font of the character A, but rather just the 8 bits of the character A. Okay, so that was the setup, and we had multiple applications that had this library, the MMConf library, baked into them, so it could capture all the input and output, and they would interact with the local Conf manager that basically did the negotiations. And there were some other negotiations that had to be, whoops, sorry. No, that's okay. Let me go back here. There was some other negotiation that had to go in terms of who had the floor. And there was this very strict, we spent a lot of time worrying about who had the floor of control. Because if two people typed A on their computer at the same time, you had to figure out how to deal with that. Well, we basically would not let you put something into the flow of things until you were given by the three conference managers authority to actually be in control of the conference. So there were some messy things like that that we had to deal with. But anyway, this is what it sort of looked like. This was the, over here was the multimedia document that we were collaborating over here. And here is a younger version of me sitting in front of a monitor for a Sun workstation and collaborating with someone over distance over. You'll notice that there's no video in this. I had no idea who the person was. And I suspect that the audio was probably a telephone call. It was not digital video audio at that point. Eventually it did get to that. So that was one node in 1985, but it was a node that was used in the paper and it served its purpose, the fact that we had implemented. Eventually, we created all sorts of different applications that worked with that library of MMConf being compiled into them. And this is one of the most sophisticated applications we developed. And it all resulted from me showing what we had done in terms of this collaboration to an Army colonel in Fort Leavenworth. And I was giving him this demo of what we could do. And he sort of pulled me aside after the demo and says, hey, I have something I want you to consider. He said, say we had a large display, which we didn't have in those days. And my people, when they have meetings, they take maps and acetate overlays and they draw various military symbols for how forces are going to interact. Don't forget, this is before the Cold War ended. So we were still fighting our battles in Germany in terms of how the Russians were going to invade us. And so he gave me this scenario. And he said, if you had a big display and you had some sort of pen that could write on that display, could you do this sort of thing that was in the lower right-hand corner there? And I said, well, not today, but let me see what we can do. Well, I took the idea back to a really creative guy who worked for me. And we came up with this whole notion of shared map viewing, which was the name of this application. And it had all the various symbols that are used in military maps. And we built it from scratch and made it work on the internet to the point where it got a lot of favorable response. And it really introduced the military to conferencing that was in their field, in the set of things that they wanted to talk about. So much, it got so popular that, let's see if I can get this now. Whoops. So popular that they asked us if we could build a portable version of a large screen. And this is before flat panel displays. And so we built, and it's a really interesting set of things we did. What he's touching there with the pen is a large CalComp plotter digitizing surface that was the size of a big screen TV with it had a matte finish on the back of the glass. And we had a video projector in that little box that was had with mirrors and stuff like that, was projecting its picture on the display. And then that pen with the wire was the CalComp digitizing pen. And so we could use that as a mouse. And we built 5 of these boxes, and they were deployed on aircraft carriers around the world and in some places in Washington to basically, again, it was a demonstration. That guy in the military uniform was actually in the accounting department, but he happened to be a reservist, so he was our prop for it. But anyway, these things were on the USS Carl Vinson in Korea, and it was pretty interesting to see how far and how quickly these guys latched on to this notion. And then we called it, as we named everything sort of engineers' names. We named it the stand-up display because you stood up in front of it. Okay, so that was one of the interesting pieces that happened with MMConf in terms of the applications. Now here's the part where Steve contributed a lot. Video conferencing on the internet was not a big thing at that time, except Steve had a project relating to the a worldwide network that was facilitated by satellite links. And they worked very hard to get video conferencing to work across satellite links. And so here's the concept of, on the right side is a workstation with MMConf running, and on the left side is a video conference, and we would try and see how successful we could do all of that. So that was the first effort at video conferencing. I said, well, that's great, except for the fact that I don't have this in my office, and I really want to be able to do these, let alone my backyard on my porch, which is what we're doing today.
Harry, was that a shared link, or they were just 2 independent links that you tried to sync up or something?
They were just 2 independent links. They were running side by side. Oh no, but the communications link was all over the wideband network. Yeah, but the devices and the systems were not linked together at all. But then this guy, Paul Milazzo, was the real brains of the operation in my department, and he came up. He's the one who wrote this program, the shared map planning. But he also, when I said to him, "Gee, Paul, can't we figure out how to get a video conferencing facility just on the workstation, sharing the windows?" And he came up with this and developed it for a Sun workstation. It was not exactly your cheap we never did anything on the cheap because everything was sort of stretching. You know, we were using, as I said, we were using $25,000 workstations, and then the boards that Paul would use for digitizing video in 2 different places was another, multiple thousands of dollars for the boards. But nevertheless, we were showing off an idea. And eventually we implemented this system called Picture Window on a Macintosh. And that's what also gave people belief that you could do these kinds of things. And we could do everything on a Macintosh that you're seeing on that picture. So that was, now, I don't claim any credit for the video conferencing because it was all Paul's work, and he did a great job of it. But there was a fair amount of activities going on in video on the internet in those days. So that was that development. Eventually, sometime later, like in 2001, I'd been into the dot-com era and come out of the dot-com era and gone back to the refuge of Genuity. That was a company that was spun out of BBN that Steve was the CTO of. And he offered me a job to come over and do what I always have done, which is create interesting demos of the technology. And so I started thinking about these meetings, and I said, boy, it's really annoying to have to come in to your desk and set all this stuff up and get it all running, then finally sit down and you have your meeting, then who knows whether it will work or not. Wouldn't it be nice to have multiple rooms that were just permanently connected to each other? There's no setting up of equipment, it's all there, blah, blah, blah. And so they gave me a room that I could outfit with the equipment that I had in mind. And we had another one eventually at another location. So the idea of being able to walk into a conference room like you do today and have the meeting just start. You don't have to, when you walk into a conference room, do anything special like getting the lights or the whiteboard or the space to hear each other working. You just walk in and, well, what about if that conference room is separated into multiple parts? That was the idea behind this. And the reason it has this funny name called Meetings over IP is that there was a protocol, and there is a protocol called Voice over IP, VoIP. And we decided, well, we'll just replace voice with meetings in general over IP. I guess you had to be there to get the joke. So anyway, the first thing is to capture the setting of the room. So I installed a number of inexpensive webcams in the corners of the room so that I could just leave them there and it wouldn't have to do anything. And I had them connected to a server machine that we had in the room. That was one piece. That was the room camera piece. And then there was the content part. And not only were was their content stored in computers, but also spontaneous whiteboard content. So we had another camera focused on the whiteboard, again, connected to a computer, so it was all digital. And then sort of bringing things together, we have, so here's the room camera, and here's the board camera, and here's basically a shared document, and you could pull up a document just by clicking on it, and it would come up into the meeting. So this was a little bit of a formalized thing because you had to have set this, you had to have announced ahead of time when setting up the meeting that I was going to use this set of documents. And so it would put all the documents up on the bottom of the display, and you can click on them and then come up into the shared space, or you could look at the whiteboard. But that was the idea of meetings over IP, which is basically, you didn't have to do a lot of explicit things during the meeting to get it to happen. In fact, less than I had to do today, because I had to go and fool around with sharing a screen and stuff like that. It was all packaged together into one thing. So I think that's probably how far along this idea went from that original MMConf application. This is all that same style of interactions. So where did it all go? Well, as I pointed out several times, we're using this very technology today that you could say justifiably started in 1985. And there are many, many collaboration products that include a content collaboration component. And I've listed a couple of them there. And I also am always careful to say, look, this idea, the essence of the idea was in the mother of all demos in 1968, and Doug Engelbart deserves a lot of credit for the germ of the idea. So the question then becomes, did I benefit from any of this? Because BBN was not a company that patented its ideas. We were essentially contractors for DARPA, and always felt a little squeamish when we started to stretch our legs to say, well, we thought up the idea, even though DARPA funded it, and they were willing to even let us do that, but somehow we didn't have the genetic makeup to really do what you have to do to patent your ideas. And research reports and client demonstrations are great, but sometimes you wonder if your work can really survive with real users. And so in September 1996, after I'd been at BBN for like 21 years, CMGI, a company that was right at the start of the .com era, approached BBN and proposed purchasing the technology that we had done in my department, the rights to develop that further. And then they approached me and asked if I'd like to become a CTO of a startup that they were going to form around this system. And so I decided after 21 years at age 49 that it was time for me to try something else. I loved BBN, and even after I left it, I yearned for getting back there. And that's probably why I went back to Genuity, because it was really a wonderful place to work. But I had a nice period outside of BBN in the .com era startup companies. So over the next 7 years or so, I worked for 3 different employers: CMGI, Genuity, and Level 3 Communications. And so benefits, well, what are some of the benefits of doing this? First of all, after leaving BBN, I had my first C-level job title, CTO, of this small startup. And as an engineer, I always poo-pooed titles and stuff like that, but title does make a difference. You get a somewhat higher salary, but mostly when you leave, because someone else has anointed you with this title and put their reputation by choosing you to someone who doesn't know you. And that really establishes you at a level that is beneficial to you when you go for your next job. I will say, though, that the benefit I got is that I was still having fun going to work. And I've been fortunate through my entire career to always be able to wake up in the morning and look forward to the day's worth of work. And I know that doesn't happen to everybody. And it was very useful that it happened to me. In the no benefit department, people sort of say, oh, you were involved in startups. Well, I did receive a good salary for the era for that title, but I didn't make any money from the stock options. I had the mistaken impression that if you were an employee of a company that was producing something really good, that you had to sort of stick with it and you keep your money invested in it just as you were hoping everybody else would. I didn't realize that all of the business C officers were selling their stock as soon as they vested. And I sort of hit myself in the head several times, like Homer is there, when I discovered that I didn't understand the game of startups. But okay. The one notable benefit is one of the companies I worked at, I received a significant retention bonus in return for not leaving the company during the downside of the .com era. And that was always a surprise to me, but it was a nice thing that happened. But this is the most interesting one for me, which is the benefit that as a scientist who publishes papers and takes notes and keep them, I gave many demonstrations of the work that we did, and we were very open about our work. And the visitors that came by my office were frequently impressed, and they went away thinking good things about what they had seen. Some of them were so impressed and they were technical that they went back to their labs and looked up the patents that BBN had on these ideas and discovered that there were none. And so they said, and there's one company in particular that I was very happy to work against later on that went and patented what they saw that I demoed that day. So some of them proceeded to implement systems that you see around today. And there's a number of them, but I'm just talking about the people who did it early on. And one was a company called Citrix, who built a system in the early days, their system was quite similar to the one that either they had seen or had read about at our site. Unfortunately for them, at the beginning of their business, another company came and sued them over a US patent that they had taken out. And eventually I was contacted by an intellectual property law firm asking about papers that I'd written well before the patent was granted, which they felt might be prior art and then essentially invalidate the suit. This was people from Citrix, I guess, that it was their intellectual property lawyer. So over a 5-year period, I was an expert witness in 3 different lawsuits where big companies were suing each other. And they wanted, in each case, the lawyers wanted me to talk about the prior art which I had been involved in, which made the patent invalid and thus could throw out the suit. I built a number of systems that were basically built out of parts that were around in 1985 that were even ready to go into a courtroom so that each juror could sit in front of one of these Macintosh workstations and see the collaboration stuff that we did early on running in front of them. That was the largest activity I did. But I can't tell you how satisfying it was to prove in court without a doubt that the work we had done indeed was worthy of a patent, and more important, well, as satisfying was that I got these guys who I thought were sleazebags, basically proving that indeed they didn't have the claim that they made. So that indeed was very satisfying. Being an expert witness was the most lucrative job I ever worked at. I called a friend who was a patent attorney, and I didn't know how much to ask for from the lawyers who contacted me, and he told me, well, somebody like you, he told me what they were earning per hour. And it surprised me no end how much money it was. And so I said, well, okay, I'll ask for that. And I did, and they without blinking their eye, they paid it. So if you ever get a chance to be an expert witness, I highly recommend it. As I say there, the engagement I had with one of them paid for one of my son's private college education, 4 years, and then some. So it was really, really lucrative. The lesson, another lesson I have is keep note for anybody listening, even now, keep notes, write papers, be on the lookout for big companies trying to steal your ideas, whether or not you have a patent. Because as I sort of say, as the conclusion of this, it was great to be in the room where it happened. And that's the end of my talk. So I'm happy to answer any questions. I haven't been monitoring any of the chat. I've just been basically looking at the screen. So if there are any questions, I'm happy to answer them. Let me see what the chat says.
You didn't mention Al Gore. I thought he developed the internet.
Well, the story that I tell is that in my role of giving demonstrations to DARPA and DARPA's sponsors, I once gave a demonstration to Al Gore of the ARPANET in his days before he really stepped up and provided in the Senate the funding for a lot of the work that went on in the internet. And so I've always had a soft spot for Al Gore in terms of he really was the person that made a lot of what we did possible. Just maybe it was a bad quote that came out that particular day.
Harry, I don't think he ever said it.
Actually, what Al Gore said in his speech was, because I heard it, he said, I gave you the internet and I can take it away.
Okay, yeah.
He was joking.
I mean, and yeah, exactly. I mean, jokes are tough when they get misinterpreted, or you have to have been there to get the joke, and so yeah.
Hey, Harry, you talked earlier about the phrase "Can you hear me?" when you're making
Yes.
communications. Isn't it ironic that when we use a telephone, which is exactly the same technology as many other things, we never ask, "Can you hear me?"
No, that's a good point. I think actually,
well, telephones don't have a mute button, so
oh yes, they do.
That we forget to push. Well, I'm talking about real telephones, not these things that we carry around with us today.
You mean those dial-up things?
You You saw it last week.
Well, gentle people, I have been on telephone conversations where I did have to ask, can you hear me?
Well, that's not the way it used to be before all this anti-regulation, deregulation stuff happened. The telephone system was the quintessential overkill in terms of quality, and we've never had it as good as we had when old AT&T ran the show. Because now you just. And the other thing is, by the way, I was talking to a blank screen with, I couldn't see any feedback or anything like that. So, my inclination is, is anybody hearing me? And so it was nice. It's nice when you hear sort of noise in the background. You can figure that something is there. I don't know.
Harry, when you were communicating early on, what kind of cabling or telephone lines were you transmitting information over to get all that data across in a reasonable period of time? The world wasn't optically cabled.
No. The earliest stuff, essentially all of the data was present already at each of the sites. In other words, if we were going to work on a document that was even a big document, there was when we introduced the document to the conference, it got distributed one time to every node on the conference. And then anything else that went on during the conference was an incremental change to that document. And so the amount of data that had to go around in real time was very small. And that was those were some of the tricks we had to play to get it to all work properly. Now, no one bothers to do that. In fact, I was showing you this very complex document today without anybody ever getting it before I decided to do it. And the reason for that is that the bandwidth, I have 70 megabits of bandwidth into my house. That was way beyond where we were in 1985.
So did it go over the telephone lines?
No, not telephone lines. We were in 1985. We were using dedicated lines that were part of the internet, and they were. I don't know the numbers. By then, it was above 56 kilobits. But there were days when I was working in the ARPANET, it was when the high-speed links were 56 kilobits. So, but by the time we were using it, they were. I don't know what the bandwidth was. Steve probably would know it better than I. All I know is that you could get small amounts of data across with low latency, but it was done through the ARPANET, so there was no. It wasn't the same. It was a higher quality connection than a dial-up telephone connection.
Harry, it's my understanding that Zoom uses the same thing today. They look at the picture and 80% of the picture that's being broadcast is static, the background
Correct.
And all this other stuff. And so they go through a very quick algorithm and say what's changed. And that's all they broadcast so that they minimize the amount of information that has to go back and forth.
That's exactly how your video picture is being transferred. It's precisely that is the algorithm of video codecs. When they compress and decompress, what they're doing is they're trying to find the static stuff. And in the back here of my image, where are we? Yeah, back there, nothing's changing. It's only around my face that it's changing, and my face, it's a small amount of movement in my lips, and that's the trick that is played in all compression algorithms. Yeah, I'm sure Cliff Weinstein could tell us a lot more about that, because Cliff was very involved in voice over the internet, and I'm sure he knows a lot about the success of other stuff. Lincoln Lab was very involved in all of this work too.
Yeah, it's Cliff. So I worked closely with Steve Blumenthal on the ARPA packet speech work. So we were with others the first to put real-time speech over the ARPANET, which was very 56 kilobits is not a lot when you're trying to do even one phone call. That was a feat at those days. And then, of course, it came, we added, video was added, but the speech over the internet and speech conferencing over the internet was stuff that we did late 70s. And
Yeah, I was gonna say that was even before all this. Yeah.
yeah, and I guess it could certainly be, and eventually it was combined with the stuff that that you were talking about, which mostly didn't was the real-time stuff. I think was the text that you showed, and the
Yeah.
rest of it wasn't yet in the early 80s, but became that what we see now.
But I
Right.
think that
Now,
what many of
now
us
we're
have to-
throwing away bandwidth all the time. You know, we don't even bother thinking about how little can we transmit when we do those big screens of PowerPoint presentations. We just we do the same thing that we do with video.
But if you go back to if you go back to the beginning of our careers, when I started in '68, I had a teletype, and I believe I was at 1200 baud. And
Right.
then the
You were lucky if you were
1200
1200.
Yeah,
Yes.
I might not,
300
I might have
too.
been less than that. And then I remember it went from 1200 to 24, and then it went to 48, and then it went up by a larger factor. I think it may have just gone up to 56 by then after that. But I remember thinking, my God, what do I need this for? It's going a lot faster than I can type. And it's going faster than my
And
my
then there was
printer could
T1
print.
too. T1 was a big deal. And I don't know what that stood for. Maybe it was I don't know.
Well, T3 was 1.8.
No, no. This is Steve Blumenthal. So in the ARPANET days, lines were 50 kilobits, and then they stepped up to 56 kilobits. Bob Kahn, our sponsor, Cliff and Harry and I at DARPA, started up a project to create a much higher speed network back in the late 70s called the wideband net. And that was the only way to get that kind of bandwidth. Was very expensive to get that with phone lines. T1, which is 1.5 megabits, were very expensive. But he got some kind of a deal on a broadcast satellite channel at 3 megabits. And when we started doing the video conferencing, we did it over that 3 megabit wideband satellite network. Initially, there were 4 nodes, one at Lincoln Labs, one at SRI, and one in Northern California, one at ISI in Southern California. And I think the 4th might have been in the Washington, D.C. area. But we had the delay. Somebody asked earlier in Harry's talk about you know, how you dealt with the delay. Well, the round trip time over the wideband satellite network was more than you know, a half a second round trip time. And the way I described the audio, the speech work that Lincoln was doing, and some of the guys in my group, and the video work that Steve Kasner at ISI and Harry and others were doing, these were half duplex conversations. You'd talk, and then you'd say over, or you'd let the other person talk. You couldn't interrupt a conversation like we're doing today. In the later 80s, we did switch that network to use T1 lines, and T1 lines are point-to-point circuits that run at about 1.5 megabits. Eventually, the NSF net came into existence in the mid to late 1980s, and that ran on a T3 backbone, which was 45 megabits. When Harry and I and some others, I went off and joined the BBN Planet, the ISP, the Internet Service Provider, and we started using optical fiber. And once we got into the optical fiber, we were running at data rates of 150 up to 10 gigabits of speed, 150 megabits to 10 gigabits with the Sonnet and SDH, the OC class of circuits, OC3, OC12, etc.
What
That
year
was kind of the
Steve?
evolution of the speed. And then the router designs were developed along the way to keep up and feed these very high speed circuits.
When did you have
Today,
the
I
10
think the
megabit?
internet, one last comment and then I'll stop. Today, I believe the internet is running over 100 gigabit or 400 gigabit lines typically between cities.
So the 10 gigabit that you talked about was about what year?
Well, at BBN, we started deploying a 10 gigabit network in 1997 when BBN was purchased by GTE. GTE bought 20,000 miles of dark fiber from Quest, and my group was responsible for lighting up that fiber, and we built about 75 POPs. And one thing we did that was kind of unusual at the time is we bypassed the SONET layer and we did IP directly on what was called dense wavelength division multiplexing, DWDM.
So
at
I
10
just,
gigabits.
I just wanted to add a somewhat different perspective. My youngest daughter got an MBA and a CPA, and then she went to work for one of the big companies, one of the big accountant companies for a while. And then she went for a startup. And what she developed was a specialty in closing down failed startups. She went, and the big lesson that she brought home was the first thing you do. I mean, people were hiring her to shut down the company. Yep. And the big lesson that she brought home was that the first thing you do is you put your salary in escrow so that you will get it when the company is gone. But and also she said after a while it just got depressing, and so she went completely out of the accountancy business and is doing something else now.
Can I throw something in here?
Going back momentarily to can you hear me? Was there ever a period of can you see me? I missed it if there was one. And if there was one, why not?
Well, I think can you see me is much less important than can you hear me?
Well, you can't even ask the question about can you see me until can you hear me has been answered.
Yeah, that's the first one. The first one is can you hear me? Because if you cannot hear me, you can never ask the question, can you see me? But I was just wondering, did the video have a similar stage?
Well, the video phone was demonstrated in the '64 World's Fair. So that was the first time, that was around that time is when AT&T had the video phone. So it must have been around that time, Tony, that the same thing happened. Can you see me?
Wasn't it called the picture phone?
Yeah. You're probably right, Charlie.
Hey, Cliff, what do you want?
I want to add a couple of things. When we did the very first packet speech call with the West Coast, I think it was 1974, the two-way delay was about 6 seconds. And we were excited that we could actually, and of course we said, can you hear me? So that now it's almost instantaneous, and that's wonderful. And can you see me? I'll just when we talk to our kids on FaceTime, we use that all the time because the kids never stay in front of the damn camera. They keep moving around, and that's a problem.
Dick Wagner?
Yeah, thanks. I have two questions, comments, whatever it is. One is, since Cliff was talking about, I think VoIP, the patent office, which I still communicate with at times, has a lecture series. And a week or so ago, the person supposedly who is the inventor of VoIP gave a talk. Now, I didn't listen to it, but the person's name, I think, is Cook, C-O-O-K-E, and you could verify if that's true or not. But the reason that she was invited to give the talk is, first of all, she's given the credit from a patent standpoint of being the inventor for it. But secondly, she's a female and she's Black. So obviously we're in this age now where we're beginning to, I don't know how to put it, but we're now recognizing those sorts of things. So Cliff, you can comment whether she is the inventor or not. I don't know. But the
I would
second,
say no. I would say it was probably that she was, I don't know. I don't know her, but like Harry said, the notion of packet speech, which was funded by the government and worked at on government DARPA programs and all that, was well invented in the early 1970s. And there have been
that's when she did it. Yeah, that supposes when she was working on it. So.
Oh, really? Okay. Well,
Yeah.
I don't know her.
Yeah.
I thought also Claude Shannon was somehow involved in VoIP.
Well, yeah, but there have been multiple little companies that have tried to patent it since. I was invited to be an expert witness against those folks, but as at Lincoln Laboratory working for the government, I wasn't allowed to do that. But I do have friends who have been, working cases on packet voice and packet video probably for 40 years. Because what happens is that it was in the open, and then various companies tried to patent it, and or sued big companies for violating their little patents. And Harry, it's wonderful that you did well on that. I think probably other people did too. I don't know who this cook is. I'll look her up. I really have no idea.
Okay, thanks. The question I have though, Harry, since I'm not a computer, well, I haven't worked with computers. I know how to program computers. I know how to use them and so forth. But I'm wondering, what is the guts of what you did or do, your everyday activities in order to make this communication across lines work? Is it basically writing programs to get the packets to go from one place to another? I'm just curious, what's the basic thing that you were doing?
Well, okay, so my whole activity has been at the very highest levels, thinking up what would we like to do, and then maybe doing some early demos. But my programming skills were never good enough to do what the guys who worked for me were able to do. And what they're doing is basically standing on the shoulders of the next level below them, which is there are libraries that implement the transmission of bits across the networks that Steve builds. And so you package things in terms of connections and feeding a stream of data to these systems. So what we do as application developers is sort of say, well, in particular, in terms of the MMConf world, we built little libraries that basically intercepted the keyboard and the mouse movements and fed them over a stream to the lower level routines that would then take it and transmit it across whatever network that they were tuned to use. So it might have been the wideband network, or it might have been the internet, or it might have been the local area network. It didn't really matter. Again, my job eventually turned into sort of being a manager, which I wasn't terribly fond of. I much rather think up ideas and write papers, but that's the way it goes. I'm not sure I've provided you with the essence of what everybody in my group did. I mean, they were programmers, and they would write up from the user interface on down to how do we take the bits and get them from one, or how do I take the bits and accept them from someone else?
Thank you.
That's probably not a very satisfying answer, but
No, actually what it does is it tells me a little bit about how this process works, within companies, BBN, whoever it happens to be.
Yeah, we were unusual. We were unusual that we did not have a cost as a moderator to what we could do. We were working with 15 years before it was economically viable, is how I usually describe the kind of things that we did.
Harry, if there was all this information,
that's the Bell Labs sort of concept.
Yeah. Yes.
Harry, if there was all this information out there, nowadays you just do an internet search to get the information. to know where these libraries of information are and who's got what technology. How did you get the information? Because that we get so easily over the internet now, how did you physically get it?
It was a smaller world in those days. So I knew all the people who were doing any of the work on this, and Steve knows all the people who were doing the work. And it was ARPA was the center of the networking universe. I don't know, Cliff, do you agree that it was a smaller world then?
Oh, yeah. It was
But not
definitely,
only was it a smaller world, but there weren't as many different things to learn. I remember in the early 70s, I taught the entire computer curriculum for Fitchburg State College, because I knew all the different subjects that were taught in the curriculum. But that wasn't very much. That was machine language and Fortran and a little bit of COBOL and some systems design stuff, and that was about it. And if you look at what the kinds of things we did back then, we developed all the libraries and other things that are now just taken for granted. I mean, I look at what my son does when he wants to develop a web page. And I think back to the early days when one wanted to develop a web page, you had to worry about all the pixels. And all that's been taken care of by a whole bunch of routines. I learned linear algebra in grad school so that I could use it to solve certain kinds of problems, which couldn't have more than about 7 rows and 15 columns, or you just couldn't compute it. And then I got to Raytheon, and I had a problem that lended itself to that. And IBM had just released an application that allowed me to deal with something with a couple of 100 rows, which was impossible to do by hand. And I think all of us have seen that over this last 50 years or whatever our career length has been.
Another example is that you had to almost be a wizard to do a tenth of what we're doing today and pull it off for an hour and a half. So this is really been a pretty amazing ride.
But also with memory, I remember doing all kinds of tricks to fit computation into the limited amount of space that I had available to me. I remember writing a Fortran program where in the 31 bits minus the sign, I was able to stick in 3 numbers, which I packed and unpacked as I did manipulation with them. And you talk to people who are programming today, where memory is more or less infinite, depending on your definition of the word. And nobody today worries about whether or not they have enough. Well, very few people worry about whether or not they have enough space on their disk or space on their machine itself.
Will they have enough space on that terabyte disk?
Right.
Yeah.
Well, John, unless you're building device drivers, in which case you have a specialized piece of equipment of putting stuff on a ROM, and then you have very limited real estate, and you have to do all those tricks. But I have a question. I have a question for you, Harry. You talk a lot about the software for sure, but was there custom hardware that was involved in a lot of this?
No. I mean, just in the content conferencing side of things, it was a plain off-the-shelf Sun workstation with all of the C environment that was available there. But there was no, for the video, we did have to add boards to the Sun workstation. They were very expensive to do that, on-screen video conferencing. And then, of course, with the wideband stuff, it was actually physically separated 2 very different systems, but that was all special. He probably could talk to that better.
Yeah, I just thought it would thank you for sharing your group's organization, because you really talked about the application software development, understanding that it goes from essentially a device driver capturing information from your input devices all the way through the presentation layer, which allows people to use it. And there's, umpteen layers in between. And a lot of people don't understand that that's really the nature of software development. for
Right.
real
I mean,
applications.
the nature of software development is knowing what to ignore, that you can just rely upon somebody else to have done it correctly. And you know, that's something that people don't always get.
Welcome to the world of black box coding.
Yeah, right.
I have a comment.
To add to you guys.
I have a comment on that point, by the way, about another BBN project or set of projects, I would say, that I was involved with, where both the software and the hardware, as well as kind of algorithms standing behind them, were equally important in order to get the job done. For example, in this particular case, we were trying, without mentioning details at all, we were trying to get an active noise control system working. And on paper, it looked very simple. We've done it many times before in other cases, but in this particular case, the filter, as we call it, namely the digital filter, had to be very, very long. I mean, it was thousands of points. And we had to essentially interrogate the system with shakers and microphones and things like not microphones, speakers, then measure all the signals and come up with an answer in a few seconds. Well, we thought we could do it until we actually sat down and started grabbing available hardware and so on. And we found out that we would get the answer. Yes, we could get the answer, but it would be 9 months. Okay. So it was not until about 1.5 years later when the boards, in that case, it was Mercury race, became fast enough. And what you could have initially on 3 racks of full racked was fitting on a single board with about 128 processors, that we were able to get it fast enough so that we can deliver the answer on time as needed. So everything was as important. And I should also mention the third word, algorithms. It turned out that when we started, the only standard algorithm that had been used until then was very, very slow. And one of the people that I had the good fortune to have working for me, he actually rigged up something else that expedited that algorithm by 10,000 times. And that was another component that made that the solution to that particular problem possible.
So, Anthony, was it that the software development was outstripping the hardware development? Was that what was happening?
I'm not sure I understood that question.
What were the algorithms getting ahead of what the hardware could deliver?
No, actually, it turned out in this particular case that there was a need of a mixed algorithm, as we called it finally, because normally when you try to do any kind of control, you have a convolution where essentially a comb filter, as they call it, samples things and gives you an answer. In this particular case, you were not doing it only in the time domain. You had to capture the signal, and the front part was done. Now I'm getting too technical maybe, was done in the time domain, and the remaining of the signal, we were taking the spectrum, adding it to another spectrum instead of multiplying things like a comb filter, and then reversing that FFT, which gave us a time series that we pasted at the end of. So anyway, the thing is that we had to come up with a total, or rather this fellow came up with a totally different approach. Both of those approaches existed for decades in the literature, but they were never combined in that way that made that whole thing possible. Did I answer the question?
Yep.
And that's the same as Harry's point.
It's 11:30, and I'm always trying to be prompt. So I think we're pretty much finished for today, unless anybody else has anything else.
That was a really excellent presentation. Thank you very much. I was at Digital Equipment Corporation,
in the R&D group, and we worked on Ethernet until 78 or so, and that's when I went to the semiconductor group. But up to 78, we worked on Metcalfe stuff and all of that. And then when I came back out of the semiconductors back into multimedia in 89, I was working on JPEG and MPEG, and then I had a whole career in the television industry after that. But all of this really echoes nicely with the discussion about algorithms, multi-layer APIs, and software algorithms are making too much demand, and then you have bugs that you have to repair down at a lower level and propagate upwards, and all of that really makes, we were fully involved with all of that, and with video conferencing as well. So thank you very much. I really enjoyed your presentation.
Yeah, good.
Well done, Harry.
Jerry Slate, you want to recruit Don Nelson for one of your being at the place where some of these inventions were developed.
I was in some of these things in the future.
Good.
So Don, put something together and we'll get it on the calendar.
Wait, I need to put it together first. The one I'm doing at the Jenks this Friday is without any material. It's just they asked me to do a 15-minute presentation. It's going to be about a 25-minute one without material. But I don't want to do it here without material.
You're just going to speak slowly. That's what it is.
Yes, indeed.
For those,
let me just say, Harry, how much I appreciate this, because I'm helping. I'm sort of the editor of a book on pleural disease as a pulmonologist, and I can get literally any piece of medical literature in the last 60 years. I can get it in less than a minute. It's just amazing how much access I have to things. It's so fast now. Everything's stored somewhere. God knows where it is. Everything has a DOI number, and all that. That whole system just has completely changed the way you get medical information. You don't have to drive into Boston to go to the Countway Library and go to the stacks and look around, and flummox around. It's so fast. And free. It's unbelievable.
Jerry, I wish I could take credit for all of the improvements you're talking about.
I thought you did it all. I thought you did it all yourself. I heard you invented spam. I heard you invented spam. Is that true?
No, I represent a class of people who thank you very much for your enthusiasm.